Okay, thanks everyone for coming. Today we have Liz and Justin who are going to talk about security stuff. Over to them.
All right, thank you very much. My name's Liz Rice. I work with Aqua Security. We are a container security company.
My name is Justin Cormack. I work at Docker and we're a container security company. There's a lot of news headlines about security recently, and we just had this 500 million web users hit by biggest hack in history. We had another 500 million users hit by biggest hack in web history just last week. And we had another one like this morning with another 100 million Quora users and things. You really don't want to be the person whose company is, you wake up in the morning and you scan the headlines and it's your company's name in the news and you realize that it's, your infrastructure that's had the problem. And so this talk is really about ways that you can try not to get in the headlines and not for only the good news to be about you.
Yeah, we're going to try and give you some practical tips that you can weave into your CI/CD pipeline. This talk contains some demos. It also has some cartoons. It also has some EU regulations. So we think there's something for everybody in this. Traditional security practices pretty much involved having some servers and on a regular or perhaps irregular basis, finding out about security advisories, figuring out that maybe some patches needed to be applied, and some poor soul manually going and applying those patches to each server in the deployment. And because it's kind of a manual process, we can think of it as a sort of sticking plaster type approach. You really can't recreate those servers very easily. It's very prone to human error. We can do better these days, right?
In these days of Docker, everything's actually quite a lot nicer from the security point of view. The first thing about containers is that they help you build a pipeline that goes all the way from building a container on the desktop all the way into production and using the same code, the same binary, the same actual container data all the way through that process. So you can do things like security scanning on that, and you know that it's exactly the same thing as you actually shipped at the beginning of the process. And this is really, really helpful from the security point of view, that you've got this pipeline. The pipeline's got automation in it, and you can add automated tests and automated processes to the pipeline. So you code, you run tests, you do the build, you configure your hosts, you run the containers, and you observe what's going on. And we're going to kind of cover all these stages of this pipeline in this talk.
And the whole thing is automated and therefore basically reproducible. So at each of the stages of this pipeline, we're going to talk about some principles that you can apply, and we're also going to show you an example at each stage. So the principles, some of them are really kind of well-known security principles, things like minimizing your attack surface or having defense in depth. And the idea is both to give you some practical sort of takeaways that you can implement yourself, but also to help you think about these principles and think about how, as a team deploying software, whether you're a developer, an operations person, a security person, you can play a part somewhere in this pipeline to improve security. So we'll start at the beginning of that pipeline with code quality. Software begins with somebody typing in the code pretty much, and there are things you can do right at the beginning to code with good practices and incorporate security. Even if you're not necessarily a security expert, as a developer you can be coding with good practices in mind. Great example of this is SQL injection. If you're writing code to handle SQL queries, you need to write that kind of with SQL injection in mind. And if you do a really bad job of that, somebody might actually write a cartoon about you. So that's something you want to avoid. And now Justin's going to show you how you can avoid other way. We'll get there in the end. Yeah, how you can avoid or use automation to detect this kind of issue.
So I've made a little web application which talks to a database, and I'm just going to bring it up. It's just a little example, very simple, written in Go. We'll have a look at it in a second. And here I've created a little script which exactly emulates the XKCD cartoon we saw earlier, because why not have Bobby tables? So if we look at the script, it's just going to basically, it's going to call this database which is running on localhost, ask it about the name Robert. We can actually just we can just see with what this does if you in a normal case. So we look for name equals Robert, and if we call that normally, it says hello Robert, you're 23 years old. Looks Robert in the database and checks how old Robert is. So that's very straightforward. If we run the script with little Bobby tables and a little bit of padding, it looks up and says, I don't know how old you are.
We got the
wrong
corrected version.
I did get stash. We just need to build the original version again. Let's build it properly.
Live demo.
Let's run this. Oops. And
you
then,
need to restart this.
Yes. Okay.
We didn't eat enough grapes, obviously.
We didn't eat enough grapes, did we? Sorry, I was supposed to do this here. Let me just... I can't type in the right place anymore. Right. Let's just bring that up there, and let's just run this here so we know what we're doing. So...
that worked, I think.
Yeah, no.
Didn't it?
Here, so it gave us the answer. It said it doesn't exist, and then suddenly, now that we run it again, it says relations to users do not exist. We deleted the database with our SQL injection. Oops. So let's actually, first of all, let's run a test on our code. That we run a standard code scanner. This is called GoSec. It's a very nice tool from HP, and if we try and rebuild our code now,
Typo.
It'll run the code scanner, and it'll see if we can, it'll run a bunch of tests on this, and we can see that it's found, with high confidence, it's found a medium severity, in this case probably high severity, SQL injection attack. Very straightforwardly, it says, look, we've done a format printf, and we put that in, we haven't properly sanitized our thing. So let's go and this type of test is actually something that static analysis tools actually tend to do extremely well, and it's actually one of the first things they find. So it's actually incredibly helpful. So if we update our code to have use the proper database query APIs, and we rebuild it, our static analysis tool will look at the code again, and this time when it checks it, it should find that it's all fine. We've managed to build our code. Remember, this is really useful because it means if there's a problem, we can't actually build our code at all, so it will never get into production, as opposed to running it there. And now we can run the injection script, and it's not up yet.
Not quite ready.
And it says, sorry, I don't know how old you are, because this is not in the database, so it's actually incredibly useful. We've basically just done static analysis. We found our SQL injection bug, and we've actually managed to put it in our build pipeline so that we won't run into these types of problems again. So static analysis is actually an incredibly useful thing to do. The other thing you need to do with your code is code review. Static analysis won't find everything. Your co-workers will find the rest.
Human eyes are really good. Two pairs of eyes are
absolutely.
Really good.
And there's actually some interesting tools coming along. Like SourceTech has some tools which actually kind of combine the two and do machine learning on code to actually find recommendations that you code review more carefully and things like that. So there's actually a really exciting set of tooling around this space being worked on. And it's something that a lot of people surprisingly don't use, and it really gives you a lot of advantages of really starting from quality when you start. And security is a kind of quality that it requires everything to be right.
So having written your code and used whatever tooling and reviewing is available to you to check for security issues, you can then also do security-related testing. We tend to think of testing as being about testing functionality, maybe about testing performance, but you can also test for security-related issues or requirements. So I think you'll be excited by this next bit. GDPR compliance, oh yes. The legislation around GDPR requires you to use encryption. And were you to be using a not very secure form of encryption, you'd probably be in breach of GDPR, and then when you lost 100 million users worth of data, somebody would come along and fine you to death. So it's a good idea to make sure your encryption is up to scratch. And as Justin is going to show you, it's another thing that you can do automatically. You can incorporate this kind of security testing as an automated part of your pipeline.
So what I'm doing here is I'm running a tool, open source tool called SSL Check. And SSL Check, basically, I'm running it against just a version of Nginx, but this version of Nginx is quite old. It's the one from Ubuntu Trusty, so 14.04, which I just downloaded. I just have in the Docker Compose file off Docker Hub. It still takes a little while to run it, so it's just coming up now. And basically what it does is it, first of all, looks to see which versions of TLS your container supports, and then it runs a bunch of tests against specific attacks like Heartbleed and Poodle and so on that. So it actually runs, tests that really attack this. So, and then it will tell you which versions and so on and so forth. So for PCI compliance, for example, you must not run any version of TLS before version 1.1, and you should probably just limit to 1.2 or higher now, because there's really not much difference in support between 1.1 and 1.2. Whereas this one, we can see, offers SSL v3, which came out even before TLS, which is really, really insecure, extremely insecure. It offers, so that's out there in red. Then TLS 1 and 1.1 are also offered, which should probably not be as well. It doesn't have the first SSL v2, which is really old. It does offer TLS 1.2, which is good because that's the currently supported version that you should be running. It doesn't have 1.3 because this version of Nginx is kind of old, doesn't have that. And now it's going to test against specific known vulnerabilities. So this is vulnerable to a CVE from 2014 called Poodle. So this kind of testing is something you can do against a connection without knowing what software is running in the container or anything about it. It just connects to TLS. It doesn't matter what kind of API it is. It could be a web server, or it could be a gRPC endpoint or anything, and you can run this test and make sure that these attacks is not vulnerable to these attacks, and that you're making sure that you're actually running the right versions, and you can add this into automated testing for your PCI compliance and things like that. So this is really, really useful, and again, it's really easy to add into automated testing, which is really important.
And you could be testing third-party images as well,
yeah,
right?
So you don't need the source code, or you don't need to know what's in it, so you don't need to scan it or anything like that. So, automated testing is not just for, code and functions and sort of tests you normally write. You can also do security testing, and there's a whole field of security testing, and this is just a little introductory piece that's really easy for people to do.
Come on, button. Maybe I'm pointing in the wrong direction. Okay.
So policies. Security policies are really important. Your organization will have all sorts of policies, and you really want to be in compliance with these policies at all times. I actually did a talk earlier, if you missed it, on the Black Belt track about policy automation, for which some advanced stuff. We're just going to talk about some simpler stuff here. So the PCI compliance regulations, which are actually very readable and very well written now. I think they used to be used to be terrible years ago, but they're actually really good, and I recommend you read them anyway, whether you're handling credit card data or not. But one of the things they say is you must apply security patches. With critical patches must be done within a month of release. You can do it quicker than that with containers. You need to rank vulnerabilities, decide which ones it's important to patch. Again, you can generally, a lot of the time, you can just apply all the patches with containers. You can just build that into your pipeline and so on. But one of the important things to do is find out if you've got vulnerabilities. So this is a screenshot from Docker Trusted Registry showing you what a WordPress container looks like if you have security vulnerabilities. WordPress is something that's had a lot of security issues over the years, and this particular WordPress example has got a large number of critical vulnerabilities, and you don't want to run this in production. So you need this kind of scanning.
And there are a few different tools that you can use to do vulnerability scanning. I'm going to show you a little demo using a tool called MicroScanner that's a free offering from Aqua. And as you can see here, we actually include this in the Docker file. So very much like with the static analysis that Justin showed earlier with that built into the Docker file, here we're running vulnerability testing as a step in the Docker file, in the Docker build. So if it fails, which it will do if it finds a high severity vulnerability, if it fails, we can fail the build and we can't then deploy an image with high severity vulnerability. So I can show you an example of that. I've got a very similar, if not identical, Docker file here. And I hopefully have in my history to save me typing it all in again. Yeah, the build command. So this is actually, the MicroScanner executable takes a fingerprint of the contents of the image, sends that fingerprint information up to what we call the Cyber Center. It's basically our massive repository of vulnerability information, and it sends back the results, which I've written into a file here called msout. That file is currently inside the container image. So I have a little script that will basically instantiate that image, copy the file out for me, and then remove the container. So I can just run that on the image I just built. And that should create a file. Yeah, just created a new file, which I will take a look at. And this is giving us a nice view of, it's in HTML format. You can also get JSON format. In this example, I actually didn't find anything very significant, 1 low and 34 negligible issues, but we can take a look at the individual CVEs and find out whether we're worried about any particular result in that output. So MicroScanner is free. There are other tools as well. There is basically no excuse not to be scanning your container images for vulnerabilities. There are open source options as well. There's a tool called Claire, which is open source. Docker, as we've seen, has it built in. Given those vulnerability results, you can have a very sort of coarse decision about whether to deploy or not based on, we can fail if we have a high severity image. You might want to have more complex rules about which images you're going to allow to be deployed. And a lot of tools exist, particularly the commercial tools and Docker's offerings around giving you rules for what level of severity or what.
Making sure you don't deploy things to production that are against your policies on CVEs.
Yeah. Okay, so that's taken us through to the point where we're deploying software onto hosts.
Secure software, we hope.
Hopefully it's secure, or at least it's, to the best of our ability, it's as secure as we can make it. And now we want to really think about making the hosts that the software is running on more secure. And the principle here is about minimizing attack surface. Kind of statistically, the more code you have, the more likely it is to include some kind of vulnerability. So it's a good idea to not have extraneous code if you possibly can. We've been looking so far at the application code that goes into your container images, and that, those files could contain vulnerabilities that you can detect through container image scanning. But there's also software running on the host itself. Now, one of the things that you can do is scan the host for vulnerabilities as well. And there's a screenshot here. This happens to be from Aqua. There are other tools, I'm sure, that will look at the packages installed on the host system and identify any vulnerable packages that are running there.
The sort of ideal state of your host is, I don't know where we came up with this plate from, but anyway, the ideal state of your host is that it's empty except for the container runtime, which runs the containers you want in production, and you have a wonderful void of nothingness doing anything else. If you actually install a whole bunch of other applications on your host that are not running containers, such as maybe databases and so on, any vulnerabilities in those applications would enable people to then attack the other containers. So that's really problematic. You really want to just run container runtime Docker on your host and literally no other applications except what's absolutely needed for for configuring the host and monitoring and so on. But most of those things should also run as containers. There's a whole set of specifications and recommendations really on what you should run on the host. So there's Center for Internet Security has worked with the community to build a whole set of recommendations around how you should run Docker, how you should run Kubernetes. There's a Docker Enterprise one, which I think is not out yet, but it's very soon, and the Windows host OS, because the original ones were Linux-based. And so these are all a set of detailed recommendations. You can collaborate in the process. It's an open process. You can sign up at the CIS website to get involved in this, and if you think there's things that should be changed or if there's things that are missing, you can ask them to be applied. And these are really kind of nice recommendations. And there's also a tool that we've got. So there's a couple of tools actually, but so there's Docker Bench Security is the original one that Docker built, and it runs as a container. It's available from GitHub. It's Docker/Docker Bench Security. It basically is a container that runs and it looks at everything. It runs with a bunch of privileges. So we've got this little script here, and so it can examine everything on the host as well as inside the container it's running in. And it'll give you a lot of information about things that are informational warnings or failures or notes about everything that's running on your host. This host, of course, this is running on is actually Liz's laptop.
My laptop is not very secure, apparently.
No, it's not very hardened. It's running a lot of privileged containers because it's got Kubernetes installed and everything that's not locked down and things like that. So it's not, and it's got some SSL check container that's and some SQL injection applications running on it as well, which are probably not very safe. But this will give you a lot of recommendations. There's also Kubernetes Bench as well, which is similar, which will give you information on Kubernetes as well. And so these are tools that you can run, and you can use them to, when you've installed the system, you can use them to check that you've actually done everything that you should have done in the configuration of the system. And that's really, really helpful in terms of actually if you want to, once you've built an automated install script, you can actually then run the test to make sure you actually automated all the right things about the setup. And especially for if you're, if you've installed Kubernetes with scripts you've written yourself, which is a bad idea, use Docker or kubeadm or something, because it's really difficult to get it right. But it'll give you warnings if you've accidentally let the entire internet use your Kubernetes cluster for free, which has been known to happen.
Yeah, and actually running those tools, Docker Bench, Kubebench, doing them on a regular basis is a good idea, just in case if something has happened to your hosts, running those tests could help you spot that things have drifted from the original results.
Least privilege is a very, very general security principle. Only give the absolute access you need to something. If you give If you just over provision access to things, then when there's a problem, things can go wrong, and that can be used to escalate into all sorts of nasty things. There's another XKCD cartoon. We got out all the old best ones today for you. So there's the make me a sandwich. No, make it yourself. You know, you're not. I'm not a sandwich server. I'm just a person sitting in a chair. Standing up, sorry, that's the other way around. Sudo make me a sandwich, and then suddenly use sudo, and the computer does what you want. This escalation with sudo is something that people do an awful lot. It's like, I can't do it, I'll sudo it. It's like, it's basically just, you have the ability to have more privileges than you with sudo, you've got two states. You've either got the, I can't do it, or the, I've got root privileges, I can do absolutely anything now. There's no sort of in-between thing with sudo. And so sudo is a really bad model for security in containers, and you shouldn't just grant all the privileges just because you can't run the thing that wants some little extra bit of privilege. So Liz is going to demo what can go wrong if you give a container too many privileges.
It's kind of interesting when you're running containers because there are ways that you can kind of inadvertently give away privileges and without necessarily really realizing that you have. So I've got this virtual machine. There is no user currently called attack. And as the user called vagrant, if I try to add it, I don't have permission to do so. But I do have permission to run containers. So let's say I'm going to run an Nginx container, and I am going to mount the etc. directory from the host into this container, and I'm going to run a shell inside it. Now, I have instantly become root, and that's not just root inside the container, it's root in the host. And I've got the etc. directory mounted from the host into this container. So now I can do this with impunity, and hopefully I can type in a password twice and get it right.
Always the difficult thing about
it is.
password.
It is. And then I can quit out of that container, and now, su into attack, if I can spell that right. I have been able to create a user, even though I, as the vagrant user, should not have had permissions to do that. Now, what I'm trying to illustrate there is how you can use, it's the fact that we've mounted the etc. directory, which I would normally not have write access to as the vagrant user, but I've given myself permissions to do so by mounting it into a container where my privileges have effectively been escalated.
And just a little bit of extra access on the host or a little bit of misconfiguration can suddenly escalate into a whole different set of things. So it's really, you have to be really careful with the kinds of access you know, special privileges or anything you grant can.
Right. And so there's definitely some best practices that you can apply to avoid this kind of privilege escalation. So we've just seen how you want to restrict the sort of mounts that you allow. You ideally, there's probably a whole host of sensitive directories that you probably don't want to be mounting into containers unless you've got a very good reason to do so.
The RBAC policy in Docker EE can actually just stop users having any access to doing any byte mounts at all because they're generally not safe. So that's one of the kind of policy items you can just set as a global policy.
Another very good practice is to set a non-root user in your Docker file so that when you run the container, you're not actually running as root. So that reduces the amount of privilege that you have when you're accessing files that are perhaps outside the container. And then the other kind of best practice, you know, it's another thing I would really like you to take away. Please don't use the privileged flag unless you really know that you need it. And you've got to know that you need it. If you don't know that you need that flag, don't use it. Okay.
So defense in depth. I mean, I think one of the important things is that, things can go wrong with security, and having multiple layers is a really, really powerful way of protecting. So, you can have one crash barrier, and then which, occasionally someone may run into, but you've got another set of barriers behind it to protect the spectators from being squashed by the car. And, unexpected things will happen, and you need to have, when something really, really sinister and weird happens and you don't know what's going on, you've got if you've got an extra set of protections, it makes you much safer. And it's really important to, also have monitoring so that so you actually know when something weird is going on, and you can actually go and take a look and see what's actually happening, and see if it's a real security problem or just something that you were not expecting and was actually normal in some circumstances.
So I'm going to show how we can detect unexpected behavior in containers, or at least how we do it with Aqua. And I want you to think about how, when you're running a container, it's probably only doing one job. So if you see something happening inside that container that isn't that container's job, maybe that's unexpected behavior, and maybe that's a sign of something bad happening. So I have an Aqua console here, and it knows about the Nginx image, and we've got a profile for Nginx, and I can look at this, and we can see that the only executable, that should be allowed in that is Nginx. That's the only thing that should ever run inside an Nginx container. And in the virtual machine, let's have a look at what's running. I've got Aqua running, and I've also got an Nginx container running. And if I look at everything that's running on my machine, and I look for Nginx, we can see some Nginx processes, but nothing else. Okay.
Everything's looking good.
That all looks good. Now, if I exec into that container, which I called Nginx, and I run a shell. Oh, permission denied. Right, so how have I done that? I've done that by, let's just make sure this log is up to date. Yeah. So basically, Aqua has spotted that I tried to run bash, which is not permitted by this profile that only allows Nginx, and therefore it's blocked that ability. I could also, I could modify my profile, so this is the Nginx profile, and put it into an audit mode. And in this mode, rather than preventing things from happening, it's going to give a warning. So I can go back to my log, and this time I've got detect rather than block. So you can connect that into your SIEM system and go, something unexpected happened, we should have an alert. And if I do anything inside here other than actually running Nginx, that's going to create more events in here that basically tell us that something bad is happening. So if I'm in enforce mode, I can actually get permission denied, and if I'm in audit mode, I can see the warnings. So we can observe the fact that something unexpected is happening inside our container. This way. Okay.
So being able to detect what's happening and prevent things happening at runtime is incredibly important. If you don't know something's happening, then attacks can remain persistent for a really, really long time. The recent Starwood attack apparently started in 2014, and it's like these people they had detection that didn't work, or they had no detection. So they didn't know that anomalous things were happening. If you don't know that that's going on, then you're not going to be able to actually do anything about it and fix it. There are actually some things you can do, even if you don't know, which I wouldn't recommend not knowing, but actually one of the things you can do with containers is to not leave them running for a long period of time. Lots of our customers will recycle every container at least once a week. Often if you're doing continuous deployment, you're doing it more often than that anyway, but you might have some long-running ones. if you make sure you recycle all the containers every week, then no one can be in your infrastructure for 4 years because the containers are only up for a week, and at least you kick them out and they have to re-attack. There's a whole lot of tooling built into Linux that you can use with Docker or with Kubernetes, which is like seccomp and app armor profiles. They're kind of complicated to configure. The Docker ships with really good defaults for these, which are general and do help, but you can write custom ones if you really need to. There's a whole bunch of commercial tools around.
I was just going to mention, because those seccomp and app armor default profiles that Docker wrote are really great. Just mentioning that if you're running Kubernetes with Docker as the runtime, I mean, I imagine you apply the defaults in the Docker implementation.
Yes,
but if you're running a vanilla Kubernetes deployment, you won't get those default profiles by default in Kubernetes.
In some future release,
hopefully that will happen.
But it's been taking a rather long time.
Yeah, but today you can add them in through annotations.
There's a whole bunch of work been going on, particularly this year, on some really exciting potential new runtimes that do different forms of isolation. So Google released gvisor in May, which is quite exciting, which runs a whole emulated Linux layer. And then there's Kata containers and the new Amazon Firecracker project, which is being integrated with Containerd, that again you might be able to use as a high isolation runtime once the code's fixed. So there's a whole bunch of exciting things going on in the runtime space as well.
So hopefully we've shown you some practical steps that you can take. We've shown you something that you can do at each of these 6 steps. You don't necessarily have to do all of them. I know that could be a lot. If you pick one thing to do, actually, let's have a show of hands. How many of you are already doing vulnerability scanning? Okay, maybe half. Yeah. So the other half of you?
Go away and do it.
Do that. Talk to your neighbour with their hand up and ask them what they're doing. Because it probably is the simplest thing you can do to effectively prevent attacks.
But the principles are the important thing. Just think about the principles. Think about, is my code as good as it could be? Have I got defense in depth at runtime? Have I got a good set of security policies? Am I actually following them? Do I know I'm following them? Have I got tests? All these things are things that you can start to think about, whether you're a developer writing code, or you're an operations person, or you're planning on rolling out a new platform. There's pieces of security you can think about in all these areas.
And you don't have to consider yourself a security expert to be able to start to play a role here. At least that's my belief. Skipped past. Very important cartoon, because obviously we've given you some advice. You might decide it's good advice, you might not. That's kind of up to you. We think it's good advice, right?
Maybe we think it's good advice.
Maybe we think it's good advice. If you want to try out some of those examples for yourself, all the code for the examples is on this GitHub repo. And I don't know how much time, have we got a couple of minutes for questions? 2 minutes for questions, if we have any questions.
Otherwise, we're around afterwards.
Yes, you can feel free to come and speak to us afterwards. So bright, I couldn't see if anybody had a question anyway. Oh, I think it was that. No, it wasn't. Somebody taking a photo, not a question.
No.
Okay, well, if there's no questions, then
okay, fantastic.
be secure.
Thank you very much.
Thanks, Bob.